Hey everybody, we use variables in math to represent numbers whose value we might not know at the moment. That's a terrible definition, but we use variables in formulas such as the formula for the area of a rectangle. Area is equal to length times width. So we use the L and the W to stand for numbers that we don't know just yet. And we just write out the formula using those variables. The length of this thing could be 6. So now all of a sudden I can replace that variable with a number. Make a better equal sign there. And the width of this rectangle is 4. So now I can replace that variable. And then I can solve using this formula, which was just full of variables, because now I've replaced those variables with numbers, and I get 24. So if this is 6 inches and this is 4 inches, your area would be in square inches. So that's how we would use variables. Another way we use variables is in equations. 3x plus 5 is equal to 17. I don't know what the x is right now. It's a variable. But as I solve this, I can find what that x equals. I would subtract 5 from both of the sides. That would eliminate this fellow right here. Bring down my 3x. 17 take away 5 is 12. The 3 is being multiplied to the x, so I would divide both sides by the 3. That allows these 3's to cancel. And 12 divided by 3 is a 4. So at first this x stood for some value, some variable that I didn't know, but with time I was able to figure out what that value was. We also use variables in expressions. Something like 5x plus 8. And I'm partial to using x's, but a variable could be any letter. And then over here to the side, I may say to you, find the value of this. And this is an expression. We call expressions, we call things like this expressions when you don't have an equal sign. Up here I called this an equation because I had an expression equal to something else. It could be another expression, but I had an expression equal to a number. The equal to sign caused that to be called an equation. Find the value of this expression if, and I'm going to tell you that I would like for you to say x is equal to 4. So how I would find the value of this expression is I would go 5x. 5x means 5 times 4. Sometimes I'll use a dot for multiplication. Sometimes I'll use this. Because I'm using x's all the time, I usually don't use the old-fashioned multiplication sign. And sometimes I'll use parentheses. So if I was doing 5 times 4, you may see 5 dot 4. That means 5 times. In the old days, I might have used this. But because I use x so much for variables, I'm not going to use that symbol very often. Or I may do this right here. All of these mean the exact same thing, and they all have a value of 20. 5 times 4 plus 8. And then I would just simplify the expression the best that I can. 5 times 4 is 20. 20 plus 8 gives me 28. Now, when you do an expression, you shouldn't bring in an equal to sign, but a lot of people do. A lot of people will work this out like, let me move this down a little bit. It won't move down. Some people may do it like this, 5x plus 8. You want me to replace the x with a 4? Sure. So 5 times 4 plus 8 gives me 20 plus 8 gives me 28. I like working these expressions down like this right here. Some people like to work them sideways. I'll let you decide which way you want to work them. Okay, so I want to do a few more expressions. So I have 3 plus 7x. I want to simplify that if x is equal to 5. So that'll be 3 plus 7 times 5. You're supposed to do multiplication before you add. So I'll do the 7 plus the 5 first, and then I'll add those together. Look how neat that is. I worked that down like that. 4x minus 16. And I would like for you to say or replace x with a 10. So we would go 4 times 10 minus 16. 4 times 10 is 40. 40 minus 16 is 24. That is an ugly 4. So that's how we work with variables. We work with variables in formulas. We work with variables in equations. We work with variables in expressions. They're just numbers that we haven't given a value yet. That's what a variable is. Hey, have a nice day.